Hey everyone, this is Mayur. Welcome to Works. In this video, we'll be doing a performance benchmarking on bunch of file formats while reading and using different libraries like cuDF, Das cuDF, and Pandas. And as part of this video, what we'll understand is some of these libraries will perform better on smaller size files, and some libraries will do better when you have large sized files. Okay. So let's get started with this video. What we'll do is first we'll import the packages. First is cuDF, which is used for performing data processing on GPU. And Pandas is regular. What we do is on CPU cores. It utilizes CPU for data pre-processing. And Dask cuDF is distributed computing plus using GPU for data analysis. Okay, it's combination of distributed computing plus using GPU. As I said, it is only for GPU. This is for CPU. This is for distributed computing with GPU. So these are three different libraries. Now what we'll do is we are giving the path of a CSV file which is 2 GB in size and a group of files which are present in this particular folder, flights underscore month. These files are around 12 files will be there per month, that is, and the data for per month, and it will be in KBs. Okay, these files are in KBs. These are small files. Okay, we have taken the file path, and here first what we'll do is we'll just load the large file which is 2 GB file using cuDF, and let us see the time taken for loading this file. So it took around almost 2 seconds, okay, using cuDF, and we'll perform the same function reading the CSV file using Pandas. This will take quite some time because Pandas uses CPU cores for reading the file, and I do have a GPU in my system, okay, around 8 GB of VRAM for that. And if we look at the result of this Pandas read CSV, we see that it has taken around 11.6 seconds, which is around 10 times. Not 10 times, it is almost 10 plus 10 seconds almost. And we'll do the same operation using Das cuDF, which is nothing but distributed computing plus GPU. So it took 23.4 milliseconds. Okay, it's not even 1 second, it is less than 1 second actually. This is the fastest one among these three. cuDF, Pandas, and Das cuDF for large file. Okay, this is the best results was provided by Das cuDF. Now, when it comes to loading a group of files, okay, using Pandas, when we try to do that, we'll be facing an error because we cannot load a group of files together in Pandas. Okay, so, and we can also, let me go back here. Yeah, so this is also not possible when we are using cuDF, it will throw the same error. But it is when it comes to Das cuDF, we can load a bunch of files in simultaneously because Dask is used for distributed computing. Okay, it will load the group of files and it will be spread across multiple cores. Okay, it doesn't need to be on the same core. It can use other cores to load these files. So this will be possible using Das cuDF, and it takes only 27.7 milliseconds for doing that. Now what we'll do is this was on CSV file. Okay, now we'll try to perform the same operation for the small file versus big file for Parquet and ORC. Here we have a file which is in Parquet format, flight underscore one. Okay, and using cuDF we are loading that file. This is small file, and it takes 36.5 milliseconds. And if you do the same with Pandas, it takes 1/3 of what cuDF was taking, 12.4 milliseconds. And if we use Dask cuDF for the same operation, it takes almost same as what Pandas was taking, Dask cuDF. So among these three, for reading a Parquet file which is a small file, Pandas is performing better. Now the same thing we'll try to do for ORC format, which is again a compressed format. Parquet and ORC are compressed formats, better than CSV file format. So what we'll do here is we'll load this file again. This is again a small file. It is taking 34.6 milliseconds. So it took 36.5 for Parquet. the cuDF. So this one is a Pandas. First, what we are doing is using Pandas. We are loading the file, ORC format, small file. Next, we'll be doing using cuDF. So it is taking less than Pandas cuDF. So probably das cuDF should take less than cuDF. Let's see. Yep, it is taking the smallest among all the three. For loading a small file, ORC format, in ORC format, just 12.9 millisecond. Now comes the important question, what will happen when we try to load large files? The whole point of doing this task is, in real time we'll be having huge data and we have to process large files. That's why we need to take into consideration large files while performing or benchmarking these libraries. So here I have a Parquet format for a large file which is 2 GB, which we had earlier, we have seen in a Parquet format. Now we are reading that using Pandas library, and it takes around 562 milliseconds, that is 0.5 seconds. When we do the same operation using cuDF, we see it is taking 4.4 millisecond. 150 milliseconds were saved from cuDF. And if we do it from task cuDF, it takes 15 milliseconds, which is less than zero point 0.1 second almost. It is 0.1 second. That's it for a larger file. Now we'll try to do the same, load the same large file using turn that into an ORC file and then try to load that using Pandas cuDF and das cuDF. So here we have in Pandas format, if we look at the time taken for this one, it is 514 millisecond, which is 0.5 seconds. And if we use cuDF, it is zero point 0.2 seconds, that is 300 millisecond was saved. And when it comes to this das cuDF, it takes only 43.9 millisecond. So what we can understand from all the things that we have done till now, for larger files, it is better to use das cuDF, and the second option should be cuDF, and the third option should be Pandas. Okay, for the large files. And if you're just getting started with some POC, or if you have a small data set, then you can start using with Pandas itself. It shouldn't cost much in time. So it is preferred if you have a large data set and if you are doing what you call big data processing, it is always preferred to have das cuDF or cuDF for processing the files. So with this, I'll be concluding this video. Thank you so much.